James Whittaker is a software architect at Microsoft. He spent his career in software testing. He was an early thought leader in model-based testing, where his PhD dissertation, sorry, James, from the University of Tennessee became a standard reference on the subject. While a professor at Florida Tech, he founded the world's largest academic software testing research center and helped make testing a degree track for undergraduates. Before he left Florida Tech, his research group had grown to over 60 students and faculty and had secured $12 million in research awards and contracts. During his tenure at FIT, he wrote How to Break Software and the series follow-ups. His research team also developed the highly acclaimed runtime fault injection tool Holodeck and had marketed it through their startup, Security Innovation. James is a frequent keynote speaker and has won numerous presentation awards. James Whittaker.
Come on, Vista. Oh, the microphone's on. All right. Thank you for the welcome. Let me just get comfortable here. All right, I'm James Whittaker. I'm from Microsoft. Be nice to me, or I will install Vista on your laptop. Lydia, thanks for the introduction. If I'd have known you were going to read the whole thing, I might have put something different in there. But here we have it. I'm going to talk to you today about the future of testing as I see it. One of my favorite quotes is that the best way to predict the future is to invent the future. So I'm going to invent it today. See how many of you all I can get to help me work on this. This is my second favorite quote because I like magic. I think the idea that our industry produces magic is incredibly accurate. And according to this definition, we've done things that most people consider to be magic. For example, in 1953, these two guys recognized that DNA had this double helix structure. And they modeled it using the medium of Lincoln logs. Now, once software was applied to this, starting in about 1990, the Human Genome Project started. I was fortunate enough to be a graduate student at the University of Tennessee that had one of the first grants from the NIH on this. Software was applied to this problem, and that's where the real magic occurred. Right? The entire genetic structure of the human being in these 13 years was mapped in its entirety. There's bits of it that are wrong, right? There are competing models, Markov chains versus neural networks versus genetic algorithms, but the entire human genome mapped within a 13-year period. This is magic. The number of diseases that will be cured because of this, the religious controversy. This is a wonderful thing, and it was brought to you by the magic of software. You know, the human genome, the DNA structure was a nice invention, but it took software to apply the magic. Planetary exploration. The impact of software on this has been absolutely phenomenal. In 1969, so people have been speculating about planets orbiting around other stars for centuries, right? All the way back to Newton and Galileo. In 1969, Peter Van de Kamp explained wobbles in Barnard's star by the presence of a planet 1.6 times the size of Jupiter. Turns out he was wrong. And we didn't find out he was wrong until 2000. About the year 2000, we began to have very clear evidence that there really is something out there, right? There's something orbiting these stars. And in 2003, the first one was confirmed, right? How did we get there? From there might be something out there to there definitely is something out there, it was software. The software that was used to design better telescopes and scientific instruments, and the software that was used to look at the data on the way back. So in 2003, the first one was discovered. By 2006, because of the magic of software, over 200 exoplanets were confirmed, right? Not speculated, confirmed. This is software doing this. I just checked this morning. 313 have now been discovered as of 6:42 a.m. this morning. 313 exoplanets confirmed, and it will be software most experts agree within our lifetime, or maybe some of the younger people in the audience, will live to the day where software models will show that there is an Earth-like planet out there. Pretty phenomenal. Take software out of the equation. We're still back to guessing and speculation like they were doing in 1969. This is a picture of an autistic girl. I don't know if you've seen this video on YouTube. Watch it. Do yourself a favor. I've got the link in the next slide. So experts have always agreed that the behavior of autistic people is unpredictable, random, and they've got problems, right? They're uncommunicative. Well, it turns out that this girl proved them all wrong by producing her own YouTube video about what the language of autism means. Through the magic of software, we were able to design a keyboard that she could communicate with and interpret the half an hour she spends playing with the water in the faucet and what that means, what she's feeling. She built this video. All the experts agree she shouldn't be capable of doing that. Her mental capacity should not allow her to be able to do this. It's been independently verified by several different research and news agencies. She did this. There's the link. Look at this. Watch this video and tell me that the magic of software isn't real. We have problems that we have yet to solve. We have global warming. Okay, you might disagree on how it's caused, but everybody seems to agree planet's getting hotter. And you look at pictures like this from all over the globe, we have a problem. Right? The computer models are showing this is a situation that's incompatible with human existence. How are we going to solve this? Except without software. Right? We have proposals on the table right now. How about we spray the atmosphere of the planet with a chemical that will deflect sunlight, and if it deflects enough sunlight, the planet will cool and everything will be okay. Right? Well, we're pretty good at spraying chemicals into the atmosphere. What is it that we're going to use to figure out the what-ifs and the maybes and the uh-ohs and even the oh shits, right? Because you don't want one of those moments after you've sprayed the chemical. You would rather have that moment before you sprayed the chemical. Alternate energy. All of the pieces of equipment that you see here were designed using software. They were optimized using software. They were made better using software. And the next generation of alternate energy sources, take software out of the equation. Go tell the people who are researching this, guys, you can't have your computers. Or you can just have the computers, but you can never change the software. Right? That's it. Take that tool off the table, and they'd all give up. It's the most powerful tool, except for the human brain, the most powerful tool that these people have. Global finance. Lydia's, your quotes were very interesting up there. Software models predicted the current situation that we're in now. Problem is there's no history to believe them because we haven't hit this before. But most major economic software models predicted the situation that we're in now. So now we have precedent. Let's listen to our software because software has the unique capability of taking all of these variables, right? Consumer spending habits, the money supply, blah, 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 blah. All of these different variables that affect the economy. There's one thing that has the power of seeing through the data, and it's software. Take software out of the equation, it's a lot harder to do. Curing disease. Again, tell the disease researchers, you can't have your software, you can't have your simulation, you can't do this. There are diseases that have been eradicated from this planet because of the existence of software. There will be diseases we have yet to see and diseases that are ravaging us now. Human life will be extended dozens and dozens of years, partly because of the brains of the medical researchers and partly because software helping those medical researchers do their job. You take software out of the equation and we have a really serious problem. Software is the one tool we need to save ourselves. But then there's the follow-on. What's going to save us from software? Now, I could talk about the fact that software has been responsible for the loss of human life. I actually used to count these in the papers I wrote for academia. I stopped counting when I got up to 100,000. In a very quick sort of review, I think it's easy to say we could add another 0 to that, right? To the loss of human life, not as a byproduct of software, but as a direct result of software. But that's too depressing. I don't want to talk about that, the loss of money and the loss of life and all that stuff. I want to look at pictures. This is a nice bug. I like this bug. I mean, you don't have to be Norwegian to know that this route sucks. How do you say, "Daddy, are we there yet" in Norwegian? I don't know. What is it that's going on here, right? Is there I'd like a pub crawl through England starting in Newcastle feature to this? Or, oh, the wife's in the car, don't drive through Amsterdam? This is a great way to deflect people to a competitor's product. This microphone really is on, isn't it? So I don't know what happened to your data. There's 3 pieces of it in row 1, so you can kind of remember what you lost, right? Here it looks sort of like this. Do you miss it? And the menus are categorically unhelpful in helping you retrieve said data. So this is a good one. Anybody staying in a hotel? All right, so watch carefully. I've taken pieces out of this to make the guilty more scared. Do you see it? See that little CGI parameter? It's called, let me spell it out for you. It's called fee, and it has 895 as a parameter. I don't know. Fee. Let's see. Might that be the amount they're charging me for internet access? Maybe. Maybe they should have called it free. Because we're in a testing conference. It seems like I'm being overcharged for that. What if I just change it? All right, now that's not, you all are testers. What value are you really going to enter here? A negative number, right? William Shatner's right. You really can get a good deal on a hotel. This one's still active, ladies and gentlemen. All right, now I removed some personal information from this, but this laptop likes to slide. So if it falls, the talk's over. All right, so picture this. This is Microsoft. This is my inbox. On, what does it say? September 14, 2006. Right? We have this internal conference we call Blue Hat. In fact, it was just last week. We invite the best hackers in the world. They come into Microsoft and they hack our stuff live, right? And show us what they can do, what kind of nastiness they can do. Well, the person who owns the Blue Hat mailing alias, which has 1,275 people on it at this time, sent out a save the date, Blue Hat's coming, because Microsofties love this stuff. And this thing sells out quicker, maybe even quicker than GTAC, I don't know, maybe not. Save the date, sends it, go to bluehat.com for more details, send, right? And then realizes, oh, it's not bluehat.com, it's an internal website, HTTP whack Blue Hat uses this message recall functionality in Outlook. Have you ever done that? Lydia's done it, I'll bet, right? Your boss pisses you off, you send this nasty email, right? You say, yeah, it's registering, isn't it? And you regret it immediately, and you recall it. So if you recall it, what happens when you press the recall is if that message has made it all the way to Pat's inbox in this case, then you'll get back an email that says message recall failure, because Outlook won't take it out of someone's inbox. But if it just made it to the Exchange server, then it will, and you'll get back an email that says message recall succeeds. So Lydia knows whether or not Pat actually saw the mail or not. So that's what happened here. Except the problem was the person who sent this sent it from the distribution list. He was logged on as the DL. So he sends out 1,275 emails, realizes, oh, wrong, recall. So 1,275 recalls go out. 1,275 message recall success or failures come back to the aliases, blast them out to 1,275 people. So 1,275 people get 1,275 emails. Do the math, it's a lot. For 2 hours that morning, we had 2 Exchange servers at Microsoft doing nothing but, this goes here, this goes here, this goes here, this goes here, yeah, right? Now that's not the bad part. So the entire company is sort of slow. 1,275 people have this. Right? 1,275 people going delete, 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 but we're Microsoft. We're too clever for that. You're in the middle of deleting, you're thinking, maybe I should write a script, but you get an email, because there's always somebody faster at Microsoft than you are. And the email says, run this script. It'll clean your inbox. You say, oh, right? And you run the script, but the script is software. And it was written by an idiot. And it actually made it worse. This was 8 hours of my day, right? Everybody else is pissed off. I'm loving this, right? Thinking, oh, this is a great story. And then there's Outlook again telling you, this one drives me crazy. You got to delete the original appointment to get rid of it. I've been reminded about this particular event, which happened in April. Over and over and over again. See, there it is. This is not an OK button. This is an OK button. I'm sorry I'm boring. I'm taking that one personally. Now, I don't know what happened to monitor number 1. But monitor number 2 has got some serious resolution. You talk about bad advice. Yeah, you just go ahead and close that and see how successful you are at installing your app. Sometimes our error messages lack a certain specificity. And just when we think they've gotten the least specific possible, we make them less specific. Just to kind of throw things. Sometimes they're too specific, right? This one's a hint to hacker. You're getting close, right? Marco Polo. And then if the hacker's not quite bright enough to figure it out, we'll tell him where the overflow is. It's right here. You found it. Congratulations. This download may take a little longer than you'd be willing to spend. And okay, you're tired of this, aren't you? Testers hate all this stuff. I can't even read this one anymore. My mind just goes into this tailspin. I fear for the space-time continuum. This is live meeting. And a human being typed this into Visual Studio. I can picture the error report. I would have loved to have written this bug report, but Adam Shostak found it first. And I can picture the look on the developer's face reading the error report and saying, oh, yeah, you're right. I forgot the period at the end of the sentence. Okay, so that's yesterday's software. Whoops, I'm doing something wrong. That's yesterday's software. What about tomorrow's? This is a video from PowerPoint. Come on now. Be nice to me. Be nice to me. Come on. This is a video from Microsoft's Envisioning project I'm going to show you. And it is a video of tomorrow's software. It turns red, so you know that that's when they're fun to take. And even the floor is a computer, just in case she gets lost. Now, there's a couple of things that bother me about this. The first thing that bothers me is that everyone in the future seems to be fit and beautiful, and I'm just not so sure that I've got a role to play in this future. Second thing that bothers me is, I should mute the microphone here, is that don't they kind of look like Macs, right? All the computers. And the third thing that bothers me, let me describe the third thing that bothers me. When this video first debuted, our vice president, we had an all-hands meeting. I'm in the developer division. I build tools, Visual Studio and such. We're watching this video, right? And our senior vice president is up there, and everybody's kind of, wow, looking at this, and oh, and ah, this is what we're going to build, and this is behind the vision. And I'm sitting in the back row because that's where I sit. And there's a guy in the back row next to me, and I look at him, and he's smiling. And I find myself smiling. And I'm wondering why I'm smiling. And I elbow the guy, and I said, "You're a tester, aren't you?" And he's smiling, and he says, and I quote, "This shit's never gonna work." Because it's software, right? I can picture it, right? She's got the little computer around. She's in a medical experiment or whatever, right? And she's got her little computer around, and her fit little hiney's running around, and it's sending his beaming data software, beaming data, and the medical researcher's got software, and he's looking at the data, and he says, right, because it's software, you know something's gonna go wrong, and he says, "Oh my God, she's having a heart attack." And so, using software, he dispatches an ambulance, and then just as she's going across the crosswalk, wham, the ambulance sent to save her turns her into roadkill. Because it's software. It's not going to work like the video. What do we need to do to make it work like the video? That's what I want to talk about. What is a vision of the future? How do we have to innovate? And I think this innovation should be driven by software testers. Because we're the ones there at the time of the bug, right? At the time of the crime. So I want to talk about the future that we need to invent to do this. And this is my 8-point vision of the future. I've been blogging about this recently for those of you who read it. I don't have time to talk about all 8. You can go to my blog and see what I've written about all 8. I'm going to talk about 3 today. And if you've seen this talk in the past, I always talk about a different 3. I've always got virtualization in there because that's the greatest hit, the one that people say that they like the most. I've never talked publicly about test sourcing, so I've added that one to it today. I want to talk to you about that one first. So test sourcing is the first point of my 8-point vision of the future of software testing. And in order to talk about test sourcing, I want to go in the past a little bit and talk about what we've been doing that has led up to this point. So I'm going to talk about 4 generations of testing. One and 2 are our past and in some ways our present. Number 3 is our current horizon present, and number 4 is the future. And what I specifically want to talk about in this is the role of the vendors, the testing vendors of the planet in each of these stages. So the first stage is insourcing. When the first software was written in the 70s and 80s and even in the early 90s, we basically hired our own testers. So we had developers, we had testers, and we tested our own stuff. That's insourcing. And in this model, vendors provide tools to the insourcers to help them do their testing better. The second generation was outsourcing. Right, let's hire somebody else to do it. And big companies, small companies, medium-sized companies popped up, some of them in the same country as a development, some of them in a different country as a development, and we provided outsourcing. Now, the role of the vendors here was to provide testing itself, right? Not just a tool. We're not going to sell you tools so you can do your own testing. We'll do the testing, right? We'll consume the tools, we'll do the testing, and we'll deliver testing to you as a service. Now, the third generation is going on now, and it's called crowdsourcing. And the pioneers in this are utest.com. Now, what happens in crowdsourcing is you basically develop your stuff and you throw it over the wall to the crowd, right? Crowdsourcing has been done in lots of different things. Social networking, photography, there's a lot of different t-shirt making, right? Crowdsourcing has worked in a lot of industries. Will it work for software testers? They got about 10,000, 12,000 software testers all over the planet signed up to do crowdsourcing. So you develop a mobile phone app, you want it tested, you write your mobile phone app, how many mobile phones can you get, in-house to test on? I don't know, 5, 10, 15, 20. Throw it out to the crowd and you've probably got all the mobile phones on the planet that exist. So it's a really nice model for certain types of applications. And in this model, the role of the vendors isn't to provide tools or testing, but to provide the testers themselves, right? We keep going up a layer of abstraction, at the same time going down to more concrete work. They're doing, people who are writing software are doing less and less and less work. UTest has an interesting model. It's really cheap because it's pay by the bug instead of pay for effort. We'll see if it works. I find it very compelling. So this is going on now. This is the near-term horizon. What I think is going to happen in the future is what I call test sourcing itself. So the role of the vendors here, let me explain this by taking it up another layer, is the vendors will provide the testing itself. Right? So what I want to be able to do is I want to say, all right, I've developed this application. Surely that something like this has already been tested. Or you can take bits of the application that I just wrote, this interface, this functionality. Someone on the planet has tested it before. Someone's got manual test cases. Someone's got automated test cases. Someone's built an infrastructure that applies to my app. Why can't I just buy the infrastructure? That's what's going to happen in the future. We're going to the entire testing is going to be to the point where we just buy the test itself. Now, how do we get there? Well, let's talk about how do we get there. Because in order to get to this vision of the future, we need 2 things. We need reusable test assets, and we ain't got that now. If I write a test, and Keith works for the same company I do, if I write a test and Keith looks at my test and says, you know what, that applies to my app, give me your test. I give Keith my test, it doesn't run. Because I tied it into my environment, my infrastructure, maybe I've got some automation DLLs, somebody's custom written, and Keith doesn't have all that stuff. So it doesn't work for him. We're going to need to solve this. We need test assets that we can just move around. Works on that machine, works on that machine, works on that machine, works everywhere. And we need shareable environments. We need to get to the point where we can run tests in lots of different environments anywhere. The crowdsourcing has an answer to this. The crowd owns the environments, and you pay them to test and find bugs in those environments. I need the environments themselves to be there, because when I go out and buy my testing, I'd like to say, okay, I need all these sorts of tests, and I need it to run on, I need it on Windows, I need it on OpenBSD, I need it on Linux, I need it on all these different platforms, I need it to run in all these different browsers. All of that stuff needs to be able to be prepackaged and sold to me as a software development organization so that I can use those test assets. So how do we get there? Well, that's the second step. And that's what I call virtualization. Virtualization technology is so real now, even like it wasn't last year at this time. It's real, it's cheap, it's powerful, and what can we do with it? We can do a lot with it. What I want to do with it is I want to solve 3 specifically hard problems. First hard problem I want to solve with virtualization is the repro problem. Stuff doesn't repro now. I find a bug on my machine or in my test lab. You ever find a bug and you just smile knowing, oh, this is a good one, right? I'm going to write my review based on this bug. And you go into your developer's office. You don't want to be too arrogant, right? You do. You want to go in there and say, all right, press that button. And they do, and it works, right? Because it's their machine. And you're thinking, damn, I just look really stupid right now. We got to solve this problem. Bugs need to be transferable from machine to machine. There's something special about my environment that causes it to fail in that circumstance. Virtualization solves this. I press a button, shrink that test case, all the environment up, send one file over my developer and say, run that. They unpack it, which all occurs in seconds now. They unpack it, run it, and it works perfectly, right? Virtualization helps with that. Microsoft has these people, these creatures called PUMs. I think it stands for Product Unit Manager. And we have this thing called a PUM effect, right? We do lots of automation at Microsoft. I mean, millions, billions, I don't know. We do a lot of automation. We get the product ready, we test the hell out of it with automation, and then the PUM wants to demo it to the VP. So we give the product to the PUM does the demo, and the software breaks. Why? What happened? This happens over and over and over again. That's why we gave it the name. Virtualization helps with this because we can build things in virtual closed environments. We can pretty much guarantee that the bugs that they might run into in a demo don't exist in that virtual environment. And then the Vista lesson. Oh gosh, I'm on film, aren't I? What happened with Vista? I don't know of I've never been part of a single product that got more testing than Vista. And we know what happened, right? We're all grown-ups here. We can talk about this. Got a less than stellar review when it was released. Why? Right? How is it that we can go through hundreds of millions of automated test cases? We can dog food it internally within the Windows org of X number of thousands of people, and we can say it's working in this. Right? And then we can give it to the rest of Microsoft, X tens of thousands of people, and they use it for months, and it works. And then we give it to a beta community, and they can use it for months and months and months and months, and it works. And then we have the early adopters who come in, buy this stuff, and they use it for months and months and months and months, and it works. And then it gets out to the broad general availability, and people look at it and say, yuck. How can that happen? What happened in all that? Well, what happened in all that, just between us testers, is the operational profile changed, right? The Windows testers, the Windows dog fooders, the Microsoft dog fooders, the beta users, the early adopters, they were all doing the same thing. And we didn't know because we had no way of measuring the difference in the environments that we were actually testing our software in. We need to be able to measure that, so we would have known when we release this thing on these other environments, it's not been tested specifically for those environments. We really don't know what's going to happen. If we could capture the environment, measure the environment, we would know. We're going to release this, and it's going to get used in ways that we don't. We knew that. We knew it was going to be used in ways that we hadn't tested. All software gets used in ways you haven't tested. Virtualization will allow us to know which was which. It was tested for these, it wasn't tested for these, and maybe in the future the software will be aware of that itself. So the solution, control the environment. It's easier said than done until 2008. Virtual machines are everywhere. I'd like to see virtual machines on every user's machine, right? This is like Dr. Watson, you know, the send, don't send. Something happened, it's bad, and send it to Microsoft and we'll fix it. Well, so that's nice. Microsoft gets this nice bug report, and there's this guy named Vince, and Vince reads the bug report and figures it out and simulates it and debugs it and then finds the developer responsible, works for them to get it fixed. Fix goes in Windows Update and everybody's happy, right? Well, that's not quite good enough. I want it better. Virtualization could give me foolproof debugging because poor Vince has to debug these things based on stack traces and static data. What if when they hit press send bug report, it shrinks up the virtual machine? Oh, privacy advocates don't like this. We'll figure out a way to take their social security number out of the data. It's okay. That's a technical problem. We can solve that. Stop complaining. And package up that whole VM and send it. And then Vince gets it, and voila, he's got debug traces while the bug was occurring in the exact environment it was occurring in. We should be able to automate the debugging and fixing of these applications over time. We could have users press a button occasionally. Create a virtual environment of what I'm doing now on the cell phone. Create a virtual environment now. They get paid 8 cents, 10 cents, right? The Google model. Google makes their billions 4 cents at a time. They get paid. They have a reason to give us their environments. Virtual machine technology, big labs, storage environment. We could get to the point where we store hundreds of millions of variations of every possible environment out there in some lab, and some American will figure out that there's a value to this, and they'll start selling those virtual machines to the testers of the world. Right? You want your software to run on 200 million machines with 1,000 billion test cases. No problem. We'll see you on Tuesday, right? We should be able to do this. There is no technological leap necessary for this vision to come to pass. Same thing for testers' machines. I would like to see the point where I have an entire virtualized test library, just add the application, right? We're testing the same applications over and over and over again, right? You got search, we got search. We want to test search. We're constantly updating search. We have this virtualized test environment, plop in the new app, boom, everything just happens. And web applications, right? Why couldn't we have a virtual environment for cross-site scripting? Cross-site scripting is the same for every application. You identify where the string inputs go. We can do that automatically. Attack surface analysis, easy. Why can't we just have a virtualized cross-site scripting environment, pop in any web app, bam, 100 million test cases, 400,000 different user environments, and it's done in 2 days. This is what we need. You want the future of that, that future is being built. Microsoft's not the only company building that future. It's happening. How are we going to test it? This is one way I think we have to test it, right? The idea is environment carrying tests. Test cases carry along the parts of the environment that they need to execute. All you need to do is find the application that test is applicable to and say, go. Right? Test me now. This is going to develop a new test market. It's going to be buying and selling of virtual machines. Buy them, sell them, rent them, create them, and sell those to the companies that are selling these things. So testing is no longer about testing. We may end up getting to a world where we don't write test cases anymore. That software testers are designers of tests. That my job as a software tester would be say, okay, here's the code you wrote. It's got these interfaces, these testing requirements, I need these sorts of environments, and I need these sorts of test cases. I go out on the market, buy those environments, buy those test cases, put it all together, and press test me now. And it happens. Right? So testers are raised up a level in the food chain. We're not down there mucking around with the individual parts of the test case and writing hand automation. We're much higher level, designing the entire test and what it should look like. The execution is for free in my future. One more. Visualization. My father worked for Ford Motor Company for 30 years, and he has the arthritis to prove it. And he worked in quality control for the last 4. Right? And I would ask him questions, because I was getting into testing at the time, and saying, how do you, when you find a bug, do you find your car designers saying that's not a bug, it's a feature. You ever heard that? And he said, no, the car's missing a bumper. We can all sort of say it's missing a bumper. And then the conversation is sort of like, yeah, let's put a bumper on it. And then my father would go back and say, it's got the bumper now. We're done. And that's the way the conversation goes, right? So what's the difference? Are people from Ford Motor Company just smarter than people from Microsoft? Don't compare us on our stock. We can't see software. That's the advantage that they have. Building any other sort of product, you can see it, right? You know the bridge isn't complete until the structures, the posts are under it. You've got this visual image that the entire team shares, all the stakeholders share. The managers see the car. The designers see the car. The repair guys see the car. The assemblers see the car. Even the freaking robots see the car. Everybody sees the car. They all agree that's what we're trying to build. What does software look like? Do we even know? Are we 90% complete? Is it just the bumpers that we have to stick on this thing, or is it missing a steering wheel and an entire drivetrain? How do you know? How do we know ship dates? This is the royal we, the industry we, not the Microsoft we. How do we know ship dates? We guess. We know ship dates because somebody more important than us comes in and says, we're shipping on this day. Right? So our job isn't to figure out if we're ship worthy or to get us. Our job is damage control, right? We've got to figure out how this thing can stink less by this day because we don't really know if it's done. So I need to see software. And I think in the future we're going to need to see software. I think in the future if we can't see software, we're going to be in big trouble because software is getting a lot more complicated. So here's the thing that I'd like to be able to see. This is software to me. Software is input, output, data flow, control flow, modules, so that structure, right, architecture, dependencies between those things, environment stuff that bothers me as software, things that might change my execution path, files, interfaces, and of course bugs, right? This is software. So what is a visualization that makes that make sense? I don't know. But I'm going to show you a few ideas that we have and we're working on. This is a visualization that we found especially useful in Windows. Vista is quite large. There's a big mystery. Ooh, how many lines of code? Is it 50 million? Is it 100 million? I don't even think we know. Once you count so high, the counting software is just like, dude, it's big. So this is a visualization of certain aspects of the Vista code base. So two aspects in particular. Size, right? So the bigger these squares, each square represents some code module in Vista, some assembly. The larger the square, the more lines of code it has. The darker the square, the more complexity it has, and the complexity is measured in fan-in, fan-out, arc density of the source code, right? And you can. We've got this tool that we've got a bunch of different things that we can pivot on, and you can see a certain aspect. This one I found good. When I started at Microsoft, Vista was almost ready to ship, and they said, oh, well, you're a tester, so why don't you go find some bugs? And this is what I used as my guide, right? The bigger and the greener the square, the more I'm going to test it. And it turned out to be an absolute gold mine. Right? When they threaten to take this tool away from you as a software tester, you know you got a good tool. And you can vary on a lot of different things. So now the task is, this was sort of proven in practice on Vista. Now these are called heat maps. They've been around for a long time. Microsoft didn't invent it. We just made it real on the largest code base perhaps in the world. You can vary on a lot of different things. So the question is, which ones are interesting, right? Which ones allow us to see the bumpers? Which ones allow us to see the bugs? Which ones allow us to see data flow through the system? Xbox is an interesting test group at Microsoft. I'm going to have to leave this conference early because we have a little internal event where the Xbox guys are presenting the next generation of this stuff. How do you test an Xbox game? Well, there's a lot of stuff you can do for automation, but they do a lot of manual testing. They hire college students, high school students, put them in a lab and say, play. Right? And then they've got software that monitors the way they play. And then you can't just say, let them play. They realize that quickly because they will play, right? I'm going to defeat this monster. I'm going to defeat this monster. It's not about the monster. It's about the bugs. Stop fighting the monster. Start finding the bugs. So how do we do that? How do we provide them tools that allow them to do this? Because games are very visual. Lots of artwork. You see objects, you see artwork, but you don't see code, you don't see bugs. There's really not a lot of dependency. The artwork, you don't see the dependencies between the background because it's a seamless user experience. So this is a GUI map. I think this is Project Gotham Racing or something like that, that allows you to, as a tester, to figure out where you are in the app. So this is running on the side, you're playing your game here, and you can see, I've just gone into this part of the world which has a whole bunch of different arcs here. There's going to be a lot of stuff to test here. Or if you've driven into a part of the application where there's nothing, you see it, you're on one of those nodes where there's only one exit arc. So it kind of gives you this, you're in an interesting place. And it works really well. This is a Fable, I think. There's a low rendering resolution for a testing tool. Where are you in the game? Now this is what it tells you. You're the red dot. That's where your character is. You press a button. Show me all the testable objects within a 20-yard radius of my character. Those are the green dots. And then you can teleport to each one of them and test those objects instead of just walking around the game. Overnight changes. So what's happening here is the game revs overnight. A lot of our games are developed outside of the United States and tested in Redmond. So you come in the morning, there's been a lot of new code added, a lot of things that have changed. You press a button, give me all the objects whose code revved overnight. Those are the red ones. And again, you can teleport to each of those and test them. And when they turn green, you know you hit the code that got changed. Very, very useful. So this is, take the entire test lab now. You got all these manual testers doing all this testing, and we collect all this stuff, render it in a low-resolution image from the game. One dot means a tester was here for a certain amount of time. The darker the dot, the black dots, more testing, more testers. The yellow dots, not so much. The green dots, not so much. A couple of things this tells us is the black stuff is tested. Stop. And we did some interesting things. You look at this and you say, all right, why is everybody collecting right there on the docks? It turned out there was a wishing well. Why is everybody finding this? I mean, we're glad it's compelling. We want the game to be fun. But stop testing the wishing well, please. And they didn't. And it kept getting darker and darker and darker. So a developer went in and ripped the wishing well out of the game, redistributed those bits to the testers, and then all of a sudden all the other stuff started getting darker. It was really a powerful thing. The other thing that was interesting is, why is no one on the boats? The boats were boring. There was no good reason for any gamer to go on the boat. So we went back to the developers and said, guys, you got to make the boats more compelling for our users. And they did, and then those numbers went up as well. So that's the idea. All right? Visualization is like Dungeons and Dragons. Did you play this when you were younger? Right? Dungeons and Dragons with the old cardboard screen and the dice, right? All you needed was a bong hit and a good dungeon master, and you could visualize everything, right? But if you didn't have those two things, you were people would sit and say, this is a stupid game, right? Because what is it? You're sitting behind a screen and you're rolling dice. If you couldn't get the game in your head, right? If you couldn't visualize Dungeons and Dragons, you hated it. If you could visualize it, it was a blast. It was a great game to play. So, now, we've built Dungeons and Dragons. It's online, right? There's World of Warcraft, there's D&D, there's RuneScape, we've built it 1,000 times, and there's millions of users all over the planet that no longer need that bong hit to really understand the game. Can we do the same thing for software testing, right? We've all got our testing bong, and we can figure this out. How do we figure it out in a large scale? I'm going to go through these quick. What does software look like for us? If the Dungeons and Dragons people can code this stuff, surely we can too. software, does it look like this? Is it some kind of document tree map where I can zoom in on a specific thing that I want and really see the software? Is it to the point where I can say, all right, show me the code coverage and it overlays it? I think it is. I think this is the future of software. Can we get to the point where we have a cockpit that shows us everything we need to know about this project? Here's the software. Here's what it looks like. You can page through it. Here's the people I'm working with. Here are all the different things in this environment that have to do with this software, right? This software looks like this, and it's kind of round, and we can play with it, and we can fiddle with it, and when it's changed, we know it, and we can see it, and when it's done, it turns green. If the Dungeons and Dragons people can make that game, that complex game, so real that they've taken the bong out of the equation, we can do the same thing too. You're going to remember this because of the bong, aren't you? All the other ideas, and it's going to be that, it's going to be that. Okay, so I think I'm winding down here. My conclusion. So I painted a vision of the future. I painted 3 of the 8 points. Go to my blog and read the other 5 if you'd like. There's a kind of a big controversy swirling on there now. If I have time, I'm going to blog again about that today. But this is what I want, right? I want software to just work. I want it to get to the point where late cycle heroics go away. This annoys me when I go into a project and I think, okay, all these people got promoted. And they got promoted because they were late cycle heroes. This bothers me. When the vice president is saying, when are you going to ship? When are you going to ship? When are you going to ship? You're thinking, I don't know, I don't know, I don't know. But you're saying next week, next week, next week. And everybody's there. Nobody's sleeping. Everybody's on. Pound, pound, pound. Code, code, code. Test, test, test. Yeah, we did it. We're heroes. Promote them. Don't promote them. Fire them. Fire them all. We don't need heroes. We need engineers. Why is it that all that activity wasn't at the front when we were designing this thing? Why isn't all that activity sort of spread over the whole project? That's the sort of future I want of software. All those late cycle heroes, fire them. Go to work for somebody else. We don't need you. We want software that just works. I want my users to be so damn surprised when they see a bug. Oh my God, it failed. Can you believe that? Look at this. This is incredible. I've never seen this before. That's what I would like, instead of hiding to see, is my wife on the computer before I go in, right? Because if she's on the computer, I ain't going inside. I'm going to go to the pub and wait, because as soon as I walk in, she's going to say, oh, there you are. This thing sucks. I'm sorry. I missed the spot. I want innovation to be absolutely epidemic. I want people to take software quality for granted. And if I seem a little over the top in my passion about this, I don't apologize for that, because I think it's going to take not just people of passion to make this happen, but an entire industry that's passionate about this. This is enough. People are depending on this, right? We've mapped the freaking human genome, and we can't make a calculator that doesn't crash rockets, right? The Ariane 5 blew up because of a calculator problem, basically. This is not right. Right? They can build bridges that last for hundreds of years. We build software that falls down in the first 5 minutes. We're better than this. Our industry is better than this. And the world needs us. The global warming people need us, right? You like to breathe? Good. Write better code. I would like it to be the point that some researcher in the year 2030 looks back and maybe picks up a copy of my book and says, can you believe this? They actually had people dedicated to finding bugs. Isn't that weird? I would like that to be just so odd in the future that they look back and say, what? This is weird. Right? Like we look back on data entry people. Can you believe that just 20 years ago, some data started its life on paper? And that we had hundreds of thousands of people all over the planet whose job it was to take that data that's on paper and enter it through a freaking keyboard into a computer. That was their job, and there were hundreds of thousands of them. That's weird in 2008. I can explain that to my 14-year-old daughter, and she's like, well, that's weird, right? Because data doesn't do that anymore. It starts out on the computer. It is born digitally. and it lives its entire life digitally. We've solved that. We've taken that entire aspect of our discipline completely off the table. We need to do the same thing with bugs. There are hard problems that we are dealing with now every single day, and at conferences like this are discussing every single week, it seems like there's a new testing conference. Which of these hard problems will simply cease to be because us, the people of our time, stood up and said, you know what? We are tired of painting lines around sticks in the road. We will be the generation that gets our lazy ass out of the line painting machine and moves the stick. Thank you very much. That's all I have. Do I have time for questions? Are there any questions? No, thank you very much. Are there any questions? I'm not serious. Yes, sir.
So I think the discussion about being able to visualize software and kind of have it turn green is fantastic. I was wondering if you had any thoughts on like what sorts of metrics would be a part of that, or if it's not typical metrics like bug incoming rates, but more about taking a holistic view of the software, the code itself.
Great question. What's your name?
Chris Smith.
And what company do you work for?
Microsoft.
Do you? Man, it's like one of those planted softballs. Here you go, James. Get ready. I'm glad you work for Microsoft. So it's none of the metrics that we're looking at today, right? I don't think MTTF and all these things that we simply don't have the data to compute, and we might not ever have the data. By the way, the International Symposium on Software Reliability is in Redmond, Washington in 2 or 3 weeks, and that is the largest metrics and measurements conference in the world, if you're interested in that. If you just, ISSRE 2008. Search for that in a search engine of your choice, and you'll probably find the site for that. So what I think it's going to be, the metric I would like to design is how many test cases didn't get run. And the future that I paint, we can't do that now. The future I paint, we can. Because I think if we can really exploit virtualization technology, we can start counting. Lydia made the comment that they're almost infinite. These things are countably infinite, right? They're not infinite. They're countably infinite. You said near infinite, so I accept that, but I like countably infinite because I took a math class once, and they said countably infinite, and I thought, what a cool term. They're countably infinite, right? There are measures we can apply to all possible test cases, all possible environments. You know, the list I showed of this is what software is, I wish I knew what it looked like, that list, those are things we need to count. Every metric has to tell me how far I've gotten on one of those things. I think that list is complete. On one of those things. Those are the metrics I want. Questions? Yes, sir.
Rick Carthage with Pillar Data Systems. It seems you want to describe a static side and a dynamic side, that there are two hands clapping in this problem.
Yeah.
And it seems to me that we can measure what a defect looks like by looking at defects and understanding the metrics that surround those, and then having our tests, knowing what our tests are doing. And maybe that goes to your environmentally contained test philosophy, that you have to know what the tests are doing. In other words, it's like hitting a target and knowing the target, I guess, is developed on the static side, but your precision in hitting the target is developed on the dynamic side.
I wish you worked for Microsoft. What a great insight. So as you're testing, what's going on in the software? Do you know? I mean, okay, so you run a few tests and you can do a code coverage report, or you can look at UI coverage, but what about while I'm doing it? I would like to see, my interface chat. So this is one of the ones I didn't talk about. This is information. I blogged about it, but this is one of the ones I didn't talk about. Information, right? In gaming terms, they have a heads-up display. So you're playing the game, and I don't know if how many of you play World of Warcraft. My 11-year-old son plays it, and I'm pretty good at hacking it. So he's like really good at this game, and the heads-up display. I like to go and just hit F11 and turn his heads-up display off, and he's like, oh, I can't play the game without it, right? Because it always reminds me of the fact that information, right? How are we as if he won't play an online role-playing game without his heads-up display meaning, you got a little mini-map of the app, you got information about you, your health, your weapons, your target out there that you might want to fight, something like that. I don't have that for software. I'd like to have it. I'd like to have, when I go into the interface, I'd like to be able to see every piece of interface that hasn't been touched, I'd like it to be red. And when I test it, I'd like it to turn different colors based on its attributes. I'd like to be able to hover over a control and have it show me the JavaScript. And I'd like to, show me the source code of the Flash component or whatever it happens to be, right? I want all that information surfaced to me just like you want dynamically while I'm testing. That was one. So see, you got a short version of that one as a bonus.
Just a follow-up question, because in your early on, you didn't mention 30 years ago there was the Strategic Defense Initiative that Star Wars, that got canceled because I think they said it was all...
It got canceled, and David Parnas, one of the most famous computer scientists in the world, moved to Canada because of that.
Amen. So rather than just thinking about testing in a gaming fashion, how do we apply this to the real world?
I think the gamers have it down. I think they've got a concept we can mimic. It's not going to be the same, right? But a heads-up display for testing, I call it THUD, right? Tester's heads-up display, THUD. So I'm working on it. It's a spare time project. I know what I want it to look like. I just haven't coded it all yet. Yes, sir.
How do you deal with state-based things in that kind of environment?
State sucks. I mean, it's one of the reasons that software testing is so difficult. You can apply all these inputs, but they were applied when the software was in state A. You put the software in state B, and you haven't tested all those inputs, right? It's completely and totally different. So being able to visualize and map data flow and state changes to the application is absolutely crucial. There's one on the list. It was on the list, right? And that's one of the things that is part of this. So whenever we get a solution and someone says, all right, this is a solution and it solves part of the problem and this is going to be part of the future of testing, that's the litmus test. What does it do for input? What does it do for state? What does it do for code paths? What does it do for data flow? What does it do for environment coverage? What does it do for all of these things? It's an excellent litmus test to know that any proposal that we make, any tool that we develop, if you're not making progress on one of those axes, we don't need it. Save ourselves the trouble. Yes, sir. Lydia, stop me when it's okay.
We've got a break right after this.
Okay.
So we can run a little bit longer.
Okay, cool.
You showed a map of mysteries, and it was really useful for
Heat map, yeah.
that. I call it heat map. What software did you use to generate that, or was it generated by person?
Some dude in Cambridge wrote it. Seriously, one of our researchers, Brendan Murphy. I don't know. So go to ISRI, because he's the program chair for ISRI this year, and ask him. He's a little English guy. Start talking to him about football. But act like, not like the football that's sort of weird shape, but the round one. He'll tell you everything you want to know. But no, that's a custom internal app. MSR gives away a lot of their tools. I don't know if that's one that they do.
This is a silly question. How do you spell heat? You said heat map?
Yeah, HEAT, heat map. Where are the hot spots? Yeah, heat map, sorry. Yeah, I'm from the South, man. I have the problem all the time. Any more questions? Yes, sir, in the back. You're a tester.
Yes, I am. Dominic Perez, Packstar Communications. Your first two chunks, it seems like there's a core dependency on componentization and standardization. For a long time, there's been a promise in software development that it'll become more like developing bridges. You'll be able to look in a catalog and get materials data sheet off the piece that you want and know that what you're going to
Dude, you took that bong comment a little too seriously, man. You need to sober up before you come to these events.
Did you have comments on how we can get there?
I don't know. So, I mean, that is the development approach to it. And there are developers that are almost as smart as we are that are working on this problem from the other end, right? And they see it as a componentization. There have been attempts, right? Patterns, design by contract, object orientation, Parnas modules. Parnas modules have the 1968, I think, he published the paper on the system to decompose systems into modules or something like that. They've been talking about this for a long time. They haven't been doing it. We still have this cowboy culture in software development worldwide. We call it agile, right? Agile is shorthand for doing whatever the hell we want to do because we're agile. It's a different approach to the problem. I would like to be able to enforce those behaviors because the metrics tell you that it's easier to get to completion if you do it this way, as opposed to let's do it this way and see if it helps us any. We've been doing that for decades and it hasn't worked. So I'm pushing this from the test angle. I mean, if you look at my future of testing, it's a disguise. We can talk, right? We're all testers. We can talk. This is not the future of testing. This is the future of software development. But it's the future of software development from being pushed from the testing angle. So I specifically don't want to take that tact because that's pushing from the development angle and it hadn't worked in the past. It might work, I don't know. But it's a race. Yes, sir?
How do you preach the possibility?
Where are you from now?
From wet paint.
Wet Paint. Wow. Nice name.
How do you preach the possibility of perfection?
Preach. Is that what I'm doing? Am I preaching? How do you preach the possibility of perfection? Just like I did it, right? Ah. Stop. Well, I do it all the time. I mean, I'm on the executive briefing staff. What do we call it? There's a bunch of people at Microsoft that talk. EBC, Alan's here somewhere. Alan's. We talk to external people all the time, and we talk about this. And so sometimes it's not fair because, you know, some of this stuff we're pioneering at Microsoft. Some of this stuff we're dropping the ball on, to be perfectly honest. I like my customers to hear this because I like to raise the expectations of my customers because that's the way you get to the senior executives, right? If a customer looks at something and says, you know what, that is unacceptable. Sorry, we don't like it. That's the strongest message you can send. So the more we educate the consumers of software, I don't like calling them users, it sounds too much like, you know. The consumers of software, I think the more pressure we get on our executives. And at Microsoft, it's nice. We have, you know, the partners in our company get compensated based on customer satisfaction metrics. So the size of their bonuses depend on how happy our customers are. So if I'm out preaching to our customers, telling them, expect things to improve, I kind of like that tact. Any more questions? Yes, ma'am.
What do you view
And who are you and where are you from?
my name is Anjani, and I own my own company called Perio in Australia.
Ah,
This company.
good luck with that. It's hard work.
Yeah, it's been really great. What do you view as the difference in education requirements for testers as opposed to developers in the future? I mean, and ultimately, if it's sort of the same path, what do you view as the differences between?
Okay, so it's not this. It's absolutely categorically not the same path. So I started a degree track program when I was a professor at Florida Tech called software testing. You could actually get a degree in software testing from my university. The Kim Kaner is still maintaining it somewhat, but it's struggling a bit since I left. Steve Ballmer actually threatened to fire me 2 weeks ago because he felt like Microsoft was better off with me as a professor than an employee. And I wasn't sure if it was a compliment or not. Right? You go home, your wife says, how was work? Well, Steve Ballmer threatened to fire me today. Oh. So I'm trying to do this now. I'm trying to drive the education, not just in academia, but down to the high school level as well. You know, we got my daughter is 14, and she creates, you know, Facebook and MySpace pages, and I try to interest her in, you know how that works, right? Right-click on that. Look, view source. Watch that. See that? You know, see the frog jumping? You want to make the frog jump higher? You want to make the frog a sheep? You want to make the sheep pink? And she's like, yeah, how do I do that, right? So I started her slow, like, all right, let's take the source code and let's just change parameters. Nothing else. Ignore all that other magic. Let's just change parameters, right? So she got to the point where she could do that. She figured out which parameter was which, and now all of a sudden she's writing Silverlight code and Flash code, and she's fairly decent at it, and she's 14. So then, you know, we've got to get them. The thing that we're doing wrong now is we're actually waiting for them to graduate from university. We're hiring them, and then we're retraining them. Alan Page is here. Where's Alan? Alan is the Microsoft's, he's the guy that teaches our new testers how to test. And I think Alan would agree with me when I say they all come in not knowing anything about it, and we have to retrain them, and that's expensive. I mean, we pay Alan way too much. And he, you know, that he's not writing code on a day-to-day basis that we ship. He's training people to find bugs, and you know, we got to do better than that. We got to push it down into the universities. That means, you know, the stuff that we do, we need more. How many academics are here? That's not enough, right? You know, I'd like to talk to everybody who raised their hand. Please introduce yourself to me sometime throughout the day. I'd like to talk to you about what we can do to help you. We, meaning the stuff I can steal from my company to give you so that you can do your job better, because I think it's very important that this take place. The books aren't good enough. The conferences don't reach out to academics enough. We're not providing them enough information that they can actually teach from, and we need to do a better job with that. I'm sure I'm way over now. Okay, thank you very much. Thank you.